The Vredefort impact structure is the largest verified impact site on Earth. This event was unimaginable in its scale of destructivity. The crater itself has long eroded away, but even with that, you cannot hide what this event did to the surrounding rocks. In its heyday, it's estimated that this crater was between 180 to 300 kilometers across when it was originally formed. If it was 300 kilometers across, that would mean it is double the size of the Chicxulub crater, which was formed by the collision that we associate with ending the reign of the dinosaurs. So in this video, we're heading to South Africa to look at the largest single impact site on our planet that we've discovered thus far. The Vredefort asteroid was an absolute monster. If it hit today, we can say goodbye to life as we know it. It was so massive that it's estimated to have been one of the largest asteroids to have struck our planet since the Hadean Eon, some 4 billion years ago. With that being said, this impact event occurred around 2,000 million years ago. How do we know? Zircon dating. Radioactive decay is very reliable, and these tiny little crystals are like the mineral versions of a USB drive, in that they store very reliable data within them, and it allows us to successfully date these types of events with great accuracy. The asteroid itself has an estimated size of between 20 to 25 kilometers, and was traveling at an intense 15 to 25 kilometers per second. As per usual, we see the typical central uplift dome that we saw in the videos that we made on the asteroid that hit South Australia, and in the video that we released yesterday, where we covered one of the largest verified impact sites on our planet that occurred in Western Australia. This central uplift dome forms as a result of a rebound that occurs post-collision. When these massive asteroids initially make contact with the Earth, the force is so tremendous that it literally melts the crust in an instant and temporarily turns it into a hot plasma, as the asteroid itself dives kilometers into the Earth. After the Earth has been sufficiently pounded, the plasma rebounds, cools, and solidifies into rock again, leaving behind these noticeable protrusions right in the middle of impact centers. In South Africa, this zone of uplift is known as the Vredefort Dome, and it consists of a partial ring of hills that are 70 kilometers in diameter. Originally, people interpreted this place as having a volcanic origin, until the discovery of shadow cones and shocked quartz in the 90s. Both of these are telltale signs of extraterrestrial impacts, as the force required to form them far exceeds the force that could be applied by any natural process that's present on Earth. Only an impact event, or a nuke, can create the types of pressure necessary to form these two phenomena. The cool thing about this place is it's a multiple ringed impact structure. Now, because this is very eroded, here's a great example of a complete one on the moon Callisto. As the name suggests, multiple rings were created as the force of the impact radiated outward, and during this event, the distortion of the Witwatersrand Basin, the Ventersdorp lavas, and the Transvaal supergroup occurred. The rocks form partial rings around the impact structure, and because the rocks of the Witwatersrand are so erosion resistant, with them comprised of silica-enriched rocks like quartzite, it's visible on Google Earth in present day near the impact center. The area where this asteroid struck is actually one of the oldest cratons to exist on our planet, with it being around 3.9 billion years old. So it appears as though this was dry land when this event occurred. But it's obvious that this didn't need to impact the oceans to cause tsunamis, as the earthquakes and pronounced volcanism that would have been triggered by this event from the enormous pressure that rippled outward in all directions was more than enough to bridge that gap. I can imagine earthquakes occurring at a magnitude far, far beyond anything that humans have seen during this, shaking literally the entire planet. Not one single stretch of land was spared during this cataclysmic situation, and much like yesterday's video, the destruction it wrought came in many ways. Firstly, this event would have made its presence known in the night sky, many months before it arrived, beginning as little more than a dot, and growing in size bit by bit as it edged closer and closer to our planet, until, one day, it suddenly appeared in a menacing way, burning bright at a size that was as large as the sun when viewed from the ground. But obviously, nothing existed back then to look up and see it, as life was more or less microscopic at this point. For reference, the Chicxulub asteroid was larger than Mount Everest. This was, at its highest estimate, double that. So imagine something double the size of Everest greeting you one fateful morning. Terrifying. As it makes contact with solid ground, a blinding flash of bright light illuminates the sky, and it grows larger and larger in size with each passing moment. The thermal radiation released by the explosion travels outward in an ever-growing concentric ring. If animals and plants were alive, they would be instantly vaporized by this. But since they aren't, only rocks were present to bear witness to this and to be blasted by the shockwave that followed. But we have everything else. Volcanic eruptions got triggered as shockwaves passed through every bit of the Earth, affecting areas on the opposite side of the planet. The entire planet shook ferociously, seemingly without end, and, as mentioned before, when these events occur, the crust where the asteroid hit is temporarily turned into a gooey, liquid, hot plasma, as the asteroid forces its way deeper into the Earth. And after that, this hot plasma rebounded, temporarily forming a mountain 20 kilometers high before dropping back in on itself and forming the central uplift zone that we see today. An astronomical amount of material is mass ejected out of the planet and into space, propelling Earth debris as far as Mars and beyond it. Much of it, however, falls back down to the Earth, and in doing so, it superheats the atmosphere, creating a situation known as a heat shock, where the air in the planet literally becomes superheated for a short period of time, further scorching everything. Volcanism in the form of supervolcanoes and flood basaltic eruptions would have definitely followed this event. Now, just to nerd out a bit, if this asteroid had have landed in a deep ocean, at its most conservative estimate, a 2-kilometer high mega tsunami would have been generated. Can you imagine how horrifying, yet awe-inspiring that would be to witness? Whew, damn. After this event, from space, Earth would have looked like hell. Literally. It was one way, only moments prior, and now it's been transformed into something that would have been unrecognizable from its former self. And this would have been how it remained for many years after this event, as Earth slowly healed from the wounds inflicted. Meanwhile, any form of life back then more than likely avoided almost all the disastrous things that were triggered by this event, with it chilling out at the bottom of the ocean floor, chowing away on the gases that were being churned out of volcanic vents non-stop. And so, this is the story of the world's largest known and verified single impact site. Thanks for watching. When the meteorite that ended the reign of the dinosaurs crashed into the Earth, the chaos that it created, though tremendous in scale, was nothing new. And that's the honest truth. This has happened and will continue to happen time and time again. And in today's video, we're going back in time to 360 million years ago, to the boundary of the Devonian extinction, to take a look at what must have been a truly cataclysmic event that possibly caused the extinction to begin with. The Devonian is often referred to as the Age of Fishes. Massive evolutionary strides were taken, and life was really ramping up its dominance of the Earth at this time, with the first plants beginning to spread across dry land during the Devonian, forming the first forests the Earth had ever seen. And by the end of it, plants had progressed from releasing spores to becoming the first seed-bearing plants, but then, almost all of it got noped out of existence, rapidly. And in this video, we're going to take a look at why. The Woodley Crater is a name you've probably heard of if you're a nerd like me, and you love researching about ancient events that more or less decimated the globe in a matter of seconds. But this crater isn't even exposed, and as a result of this, estimates of its size are conservative at best. Some state the event might have left a crater 120 kilometers in diameter, and recent studies have provided an even larger estimate, predicting the crater could have been as large as 160 kilometers in diameter. The largest estimate, if correct, would make this the fourth largest confirmed bolide impact structure in the world, and would suggest the rock that crashed into Earth was about 5 to 6 kilometers in diameter. So if this crater wasn't even visible, then how do we know it exists? Good question. You know how it goes. Human wants resources, human drills for resources, human makes discovery. In the 1970s, this structure was first intercepted. But with the limited knowledge back then, it was only realised in 1997 during a gravity study. And you can see why. I mean, look at this, it sticks out like a sore thumb. After this gravity study, a second drill core sample was taken, and it was evident from the thin veins of shocked quartz, breccia, and melted glass that the sample was composed of, that it came from something that created a level of pressure 100,000 times greater than the atmospheric pressure at sea level, or up to 100 times greater than those generated by earthquakes or volcanic activity, meaning only a large impact event could have generated the conditions necessary to create this. This was further supported by the discovery of an extremely rare mineral called radite, which was found in a drill core sample, which was taken from the central uplift zone. So what happened when this enormous chunk of rock hit the Earth? Well, bad things. Even though the impact occurred in the extremely ancient land of Western Australia, the part that it landed in was unfortunately a shallow sea, meaning tremendous mega tsunamis were generated that would have travelled outwards in all directions, slamming into every coastline within a direct firing line before inundating vast swaths of land as it poured inland ever more. And along with this, pronounced volcanism would have been triggered en masse when contact was made, as a result of the shockwaves that were produced. These shockwaves travel tremendous distances, especially when a bolide this large strikes the Earth, so it's likely that this event, or it combined with the many other disasters that it created, might have been a catalyst to the series of pulsated extinctions that occurred in the late Devonian, possibly as a result of it triggering volcanism, from supervolcanoes to starting brand new flood basaltic eruptions. And a flood basalt event did indeed occur around the time that this impacted. The ocean ecosystem relies on phytoplankton, which obtain their food primarily through photosynthesis. Like land plants, phytoplankton have chlorophyll to capture sunlight, and they use photosynthesis to turn it into chemical energy. So when events like this occur, you can bet the sun is going to be shrouded for an uncertain amount of time, until things finally begin to settle and stabilise to some extent. This isn't only because of the impact though, it's also because of the volcanic eruptions that it triggered, almost certainly leading to volcanic winters, alongside the already terrible event that has occurred, which in itself shrouded the Earth as well as a result of the ash cloud formed by the vaporized material, which spread out in all directions. And the combination of the two would have shrouded the planet, possibly ushering in the period of glaciation known as the Flaminian glaciation event. So when this bolide made contact, the first thing that happened was everything in the immediate radius of it was vaporized in an instant. Beyond that, the shockwave rippled through everything in its path as it expanded outwards in an ever-growing concentric movement, travelling unbelievably vast distances, propelling everything that it made contact with and causing untold destruction. Entire forests were destroyed, mowed down like they were little more than flimsy sticks. In the actual epicenter, the asteroid sinks deep into the Earth, like a hot knife through butter, sinking kilometers into the Earth. The solid ground that the asteroid hits gets melted into a hot plasma, losing the ability to be solid for a brief period of time, before it finally rebounded, forming this protrusion that we can see on the gravity map. The very same looking protrusion that was also witnessed in the video that we made on South Australia's Acraman impact crater. The link to that video is in the description. Material is blasted out into space, where much of it falls back to the Earth as superheated material, sparking forest fires all over the globe, and heating the atmosphere to such an extent that heat shock occurs, which scorched the entire Earth. Some material remained in space, where it then orbited the Earth and periodically crashed back down into it, only serving to further extend the destruction for many years beyond this event. So you can see why this extinction event was so pronounced. The brief cessation of the ability to photosynthesize sunlight led to the mass die-out of plankton, causing the entire food chain to collapse, and thus the mass die-off and extinction of many species occurred. Along with everything that's been mentioned, these events are also suspected to trigger flood basaltic eruptions, which is an abnormal upwelling of tremendous amounts of fluidic basaltic magma that pours readily out of the Earth and lasts for vast periods of time without any real cessation. Events such as the Siberian traps lasted up to 2 million years, and around the time of this impact, something known as the Hangenberg event occurred. I believe this to be of flood basaltic origin, but many theories have been made. To me, when combined with the Woodley impact and the short glaciation that occurred, these events are the most logical series that tie in neatly with one another, but I could be wrong. I think bolide impacts like this really serve to show us how dangerous it is to not take these kinds of events seriously. If something like this happens today, I honestly can't even fathom what would occur. All that I know is that this is going to happen again, and when it does, I can only pray that we're prepared to deal with it before it makes contact with this beautiful planet. Or else, we'll be joining the dinosaurs in the annals of history. Thanks for watching. Did the largest impact site known on Earth occur in Australia? As of 2024, it appears as though all signs are pointing to a yes regarding this question. The Denaliquin impact site was announced late last year in 2023, though studies into it began in 2022, and I've been watching closely ever since then. After scouring Google Scholar, we have many signs that an impact with a size of 520 kilometers or 323 miles occurred here. This would make it the largest known impact site on our planet. For comparison, the largest proven impact site occurred in South Africa, with a crater size of 300 kilometers or 165 miles, and we've already released an episode on the Vredefort impact site. The link to that is in the description down below. If the Denaliquin impact site turns out to be true, it would be almost double the size of the ancient impact site in South Africa. That is jaw-dropping to say the least. For further comparison, this is almost 4 times larger than the Chicxulub crater, which wiped out the dinosaurs. This impact site is associated with a period of glaciation known as the Hernantian glaciation event, and if it occurred, it is projected that it eliminated 85% of species on our planet. The date this asteroid is estimated to have made landfall is in the late Ordovician, between 445.2 and 443.8 million years ago. It's worth noting that many of the gold deposits in Victoria were deposited during this time. Is there a relationship between the two? There's actually a strong possibility in this case. It might be why the Bendigo goldfields were so incredibly enriched in comparison to any other area in Victoria. And it also might be why areas around Malagal featured the largest gold nuggets in the world. So in this video, we'll be using magnetics to scour the landscape, and we'll be looking into what forms of evidence currently exists. We'll also explore what it means in terms of mineral deposition. From what I can see, there's an evident central uplift dome, and a multiple ringed feature like what occurs at the Vredefort impact site. It's worth noting that these are rare on Earth, and they usually occur on other planets and moons. The issue? This proposed impact site is buried deeply beneath the recent sediments of the Cenozoic-aged Murray Basin. So far, drill cores have failed to intercept any shocked quartz, shatter cones, and other impact-related phenomenon, which are telltale signs of major impact events. This doesn't mean the asteroid didn't impact here. On the contrary, it means we need to drill deeper. Unsurprisingly, the proposed impact site takes its name from the town of Denaliquin, which is where the central uplift dome appears to be. I will show you this in a moment, but before I do, it's worth mentioning that post-impact, Silurian-aged magmatic intrusives occurred here, depositing granites into the crust. The Silurian occurred after the late Ordovician, and spanned between 443.8 million years ago to 419.2 million years ago, and these granites might be associated with the impact event. On the magnetics, we have a feature that appears to be the central uplift dome, followed by radial rings all around the site. There are also radial fault lines. The proposed impact was certainly huge in its scale, with the possibility that it stretched from an area just past Mildura all the way to Wagga Wagga, and it affected areas in northern Victoria too, including the famed goldfields, with the possibility that it extended all the way down south to Sunbury. On a side note, if you like this content, please hit the like button to help YouTube promote the video. We also have a Patreon if you would like to support this channel. The link to this will be in the comment section and in the description down below. Now back to the cataclysm. Extreme glacial and an extinction event where approximately 85% of all Ordovician species died occurred around the time the Denaliquin impact site is dated. Widespread glaciations and a drop in sea level of about 80 meters persisted into the early Silurian. It's very possible that this is the reason for such pronounced effects on Earth. The Denaliquin impact site is buried by at least 300 meters of recent sediments. It doesn't appear to outcrop anywhere, and it is assumed to be a deeply seated site. This impact has remained hidden for a long time due to the fact that the area where it occurred underwent a tectonic event known as an orocline. An orocline is a geological term used to describe a large-scale bend or curvature in a mountain belt or orogenic belt. This bending usually occurs after the initial formation of the mountains, and it often results in a noticeable change in the orientation of the structures within the belt. Oroclines are typically associated with tectonic processes, such as collision and subsequent rotation of tectonic plates, which can cause the original linear mountain ranges to buckle and bend. This happened in northern Victoria and southern New South Wales. The orocline in Victoria to southern New South Wales, specifically the Lachlan orocline, formed during the Silurian to Devonian periods. This large-scale bending and reorientation of the Lachlan fold belt occurred approximately 440 to 400 million years ago. Did this impact site contribute something to this orocline? Whilst this question currently remains unanswered, it's definitely something to consider. So what would have happened when this impact occurred? Well, the Earth would have turned into a hellscape. Firstly, it would have carved through the bedrock and produced a massive cauldron of molten material. When asteroids impact the Earth, a rebound effect occurs in the centre of the impact site, leaving behind a central uplift dome. It would have created violent megatsunamis, and it would have produced the largest earthquakes known to man. A quake so powerful it would have been felt in every part of the planet. When it impacted, it would have ejected vast amounts of material into the atmosphere, only for it to rain down as fiery debris-laden balls of sedimentary hell. It would have raised the temperature of the atmosphere to unthinkable levels, and the ejector released would have shrouded the globe for an unthinkable amount of time. This is why it's linked to producing the Hernantian glaciation event, as it would have blocked incoming sunlight and plunged the temperatures of the Earth by a drastic amount. While studies are preliminary, it is agreed that we need to drill much deeper to attempt to intersect the proposed impact site. If we find anomalies in the rock like shocked quartz and shatter cones, this would fully confirm that this event occurred. But there's a chance the mid to upper levels of metamorphosed rocks have been eroded, and there's also the possibility for deep mineralization, as it would have turned a land into a molten crater, melting and sequestering gold, copper, silver, and other valuable commodities that existed in the crust at that time. Due to the heavy specific gravity, these would have sunk to the lowest depths of the impact site. The Vredefort impact site in South Africa is one of the most gold-saturated places to have ever been discovered. The gold lies within conglomerates inside the impact site. A similar thing may exist in this part of Australia. But what do you think? Do you think this was a major asteroid impact, or are the features in the land merely a part of the many tectonic events that Eastern Australia underwent from the Cambrian onwards? Let me know in the comments. And as always, thanks for watching. The Late Devonian extinction was one of the worst mass extinctions that our planet has witnessed. Between 70 to 80% of animal species were wiped out. The Devonian period occurred from 419 to 359 million years ago, and, well, it was a truly fascinating time for the life that would, unfortunately, be snuffed out by the culmination of events that triggered the two major waves seen in this global die-off. As time progresses, it's seeming more and more like Australia was the site of origin for this unbelievable tragedy. And in this video, I'm going to explore the relationship between the Woodley crater impact and the supervolcanic eruptions that occurred en masse in Australia during this time period. And on top of this, there's one more event that might have been so much worse than both of these combined. Literally. If you haven't already watched the video that we made on the Woodley crater impact, then the link to that is in the description below. Alongside this, last year I made a video discussing the immense wave of volcanism that the state of Victoria experienced during the Devonian, beginning in the early part of it and peaking towards the end. All of these videos will be in the description for anyone wanting to dive into this topic further. This volcanism was to be expected to some extent, but I can't help but feel like the impact event was what led to it ramping up in its level of destruction. To set the scene, this wave of volcanism has been hypothesized to have directly caused this extinction event on its own, without the need for the Woodley impact event. It was that pronounced. But the two combined makes this bad situation a hellish one. But this isn't all. I'm still yet to make a video on the East and West Warburton impact sites, which are still being studied. The land here bears the trademark signs of a major impact event, with shocked quartz and shatter cones being evident across a vast stretch of land. It's thought that these massive bolides were actually joined at one point in time, with them splitting up just prior to smashing into the centre of Australia. If that's the case, then this would have been the largest impact event on our planet, dwarfing even the one in South Africa, which we also made a video on. These craters, when combined, are 400 kilometers in size, but since it appears that this asteroid split before impacting, it can't claim the title for being the largest singular impact event, as it was 2, not 1. Now, the reason I'm mentioning this is because this event is also dated to having occurred in the late Devonian. So, as you can see, a lot of crazy stuff went down in the 13 or so million years between, say, 359 to 372 million years ago. In Victoria, we have numerous eruptions occurring at a supervolcanic scale, and this might explain an oddity that's baffled me for a long period of time. Why did the westernmost part of Victoria suddenly become volcanically active again, randomly, after 140 million years? An impact event could certainly explain this. But in regions where volcanism was expected, such as here in the Cerberian caldera, which was near an active subduction event, or to the very east of Victoria, in Buchan, where a rift event was occurring, creating some of the most intense volcanic eruptions that this state has ever witnessed. So, in my eyes, the volcanism obviously came first. The planet was already beginning to be greatly affected by the massive amount of volatiles that were being released, with volcanic winters being more or less commonplace around this time because of how explosive the events were. Then we add 2 major impact events on top of that, one that's confirmed and the other looks to be spot on as well, as shocked quartz and shatter cones can only be formed by bolide impacts or nukes. And obviously, the fissures of the Devonian weren't nuking each other, or were they? The Woodley impact event is dated at 364 million years ago, plus or minus 8 years. The late Devonian extinction began 372 million years ago. So if we added 8 million years to this, well, this coincides almost too perfectly. The Warburton impact events aren't as concise, with a large gap occurring in the dating, with it being estimated to having occurred between 300 to 360 million years ago. For the sake of this video, let's assume it occurred 360 million years ago. So now that we have the dates laid out, let's go back to the volcanism. In Victoria, the volcanics here were raging, but they peaked in the late Devonian, and by peaked, I mean they kind of went absolutely insane. Every part of the state was releasing massive explosive eruptions. Mount Macedon, Mount Dandenong, the Acheron caldera, dozens of calderas in the rift zone, and a strange reoccurrence of explosive felsic eruptions in the ancient Cambrian zone of Victoria, in the westernmost part of the state, were all active at this time. And because much of Victoria was still submerged beneath a shallow sea, many of these, including the largest supervolcanic eruption released by the Cerberian caldera, occurred in a submerged state. They weren't released in the open air, changing how the volatiles released affected the ecosystem. There's a mention that when this extinction event occurred, it did so in pulses, and alongside these pulses were sporadic periods of glaciation events that would come and go, seemingly at random. These fit in perfectly with what would happen if major volcanic eruptions were occurring, due to the volcanic winters they produce. But in general, the extinction is separated into 2 major events. The Frasnian-Furmenian event, which started this extinction off at the date of 372 million years ago, saw the extinction of 50% of genera and 19% of all families. On top of this, a glaciation event occurred in the late Frasnian too, which serves to corroborate our speculations to some extent. I believe the Woodley impact event might have been the catalyst for these eruptions to flare up in their level of destructivity 372 million years ago. But it's not only the explosive side of things. Massive, and I mean massive amounts of intrusives penetrated Victoria around this time. And it's possible that this was due to a gigantic upwelling of magma that rose up from the mantle, spurred on by the shockwaves produced by this cataclysmic event, or maybe that was just bound to happen. Either way, we need to take everything into account. So 372 million years ago, the Woodley bolide smashed into Western Australia and caused untold devastation. In my opinion, it triggered many of the volcanoes in Victoria, and obviously around the world, to erupt. but my focus is on Victoria. I believe these eruptions occurred in tandem with the impact event, and it led to a literal snuffing of life due to the collapse of ocean ecosystems, as the sun was blocked for an extended period of time, owing to the volcanic volatiles combined with the unbelievable amount of debris that was catapulted into the stratosphere and beyond by the asteroid impact. And this also triggered a major flood basaltic event too, which only served to add more fuel to the fire, so to speak, by releasing even more volatiles and further preventing the ability for the sun to properly penetrate the Earth, meaning nothing could photosynthesize. After this, a glaciation event occurs, and during this time, volcanism continues to rage on prolifically across Victoria. Now, it's possible that this volcanism was all that was required to trigger the second and last major extinction event, which occurred 360 million years ago, known as the Hangenberg event. But if the Warburton meteorite did actually smash into Western Australia at the 360 million year mark, then it's obvious that the same thing that happened at the 372 million year mark occurred again, only on a much grander scale than it did with Woodley, as Woodley is literally dwarfed by just one of the Warburton craters, let alone two of them. One thing is certain, something caused a deadly level of ocean anoxia. That is, a lack of oxygen prohibiting decay and allowing the preservation of organic matter. This, combined with the ability of porous reef rocks to hold oil, has led to Devonian rocks being an important source of oil, especially in Canada and the United States. The Hangenberg event can be recognised by its unique multi-phase sequence of sedimentary layers, representing a relatively short interval of time with extreme fluctuations in the climate, sea level, and diversity of life. The entire event had an estimated duration of 100,000 to several hundred thousand years, and this would fit in line with what would occur as a result of volcanism and an impact event. But on top of this, flood basaltic eruptions did occur during the Hangenberg event too, and as you can see, the list of flood basaltic eruptions occurs perfectly in tandem with the timing of the Woodley impact and with the later Hangenberg event. Both had associated flood basaltic eruptions. This, in my eyes, is a strong case to argue regarding what caused the Devonian extinction. And this is just taking one state in Australia into account, because I know this place like the back of my hand. This doesn't take into account all of the other subduction or tectonic rifting events that occurred during this time, which had volcanoes that definitely would have gotten triggered by either one of these impact events. But what I have presented is enough to completely mess the world up, and to create the conditions necessary to form an extinction event at a scale as disastrous as the one witnessed during the late Devonian. What do you guys think? Do you think the Warburton impact events were what created the final purge in the very late stages of the Devonian, or do you think something else caused this? Let me know your thoughts. So this is my attempt to connect the dots to explain one of the worst extinction events that our planet has witnessed. What a terrifying time to be alive. Nowadays, the volcanoes that release these cataclysmic scale eruptions can be seen all around Victoria, from the picturesque Mount Macedon to the Cerberine caldera. But behind the beauty is a fiery and destructive origin. Thanks for watching. A mega tsunami is a truly terrifying event. Thankfully, they're quite rare. It takes certain specific conditions to generate them. But in general, the predominant ways that they will be created is following a landslide, meteorite strike, man-made explosive detonation, or large-scale caldera-forming volcanic eruptions that occur near to or directly impact a large body of water. I might be missing a few other ways, but you get the idea. Massive splashes, basically. Something like this occurred in Lituya Bay, which is located in Alaska in 1958, when a gigantic 524 meter or 1719 foot high mega tsunami was created after a magnitude 8 earthquake dislodged a massive amount of rock on the side of a cliff face, which fell directly into the bay below, spawning a tsunami that was truly the stuff of nightmares. So in Australia, we have widespread evidence of a truly cataclysmic impact event that happened fairly recently, and an associated mega tsunami which inundated almost all parts of the western and southern coastlines of Australia. A large comet slammed into the deep waters of the Indian Ocean, and it's thought this comet fractured into 3 pieces, 2 of which were much smaller and appear to have landed in different spots in the Pacific Ocean, making this a global event. And the reason we know this is because the rainout from these impact centres overlaps with the ones in the Indian Ocean. as this event also caused a worldwide deluge that lasted for weeks on end, as it vaporized an incredible amount of seawater, which upon impact was converted into an immeasurable amount of water vapor that would then go on to travel with the prevailing winds around the globe, taking several days after this event to finally cool down based on studies, and the link to this study will be located in the description below. But after this water vapor finally cooled down, it would finally be rained back down to Earth in a truly biblical proportion kind of rainstorm, and biblical proportion might just be the best way to describe it, as this rainstorm coincides with the flood stories that were told globally by over 150 different cultures. This comet was a Shoemaker-Levy type of impact. The comet Shoemaker-Levy 9 broke apart in July of 1992, and it collided with Jupiter in July of 1994, providing the first direct observation of an extraterrestrial collision of solar system objects. This generated a large amount of coverage in the popular media, and the comet was closely observed by astronomers worldwide. So the collision that occurred in the Indian Ocean was caused by a comet similar to the one that slammed into Jupiter. It's a comet, not an asteroid. The difference is an asteroid is made up solely of rock, whereas comets are a mixture of rock, ice, and gas. If this was an asteroid, the impact would have been far, far worse, especially if it was a heavy iron-rich asteroid. The mega tsunami would have probably been at least 1 kilometre high if that occurred. The capital city of Western Australia is Perth, and as of today, it has close to 2 million people living in this city. It's one of the many places that were built atop the remains of the deep sea sediments that were dredged up and carried over here by the mega tsunami following the collision, which, by the way, left a 30-kilometre wide crater after the comet had struck. But when it collided with the bedrock of the Indian Ocean, sand, mud, volcanic material, and whatever else existed on the almost 4-kilometre or 2.5 mile deep section of the Indian Ocean where this comet struck, got blown out in all directions. A large part of it was thrown into space as well, but the majority of it would be carried by the mega tsunami that was generated, only to be dumped here en masse 5,000 years ago following this event, changing the entire landscape literally in the blink of an eye, by converting the previously flat land into a landscape dominated by sandy hills that were comprised of deep sea fossils, mud, and obviously, sand. Core samples taken from these sediments feature deep sea microfossils that are fused to extraterrestrial metals, and these metals could have only come from this type of event. So in this video, we're going to nerd out on the geography of Perth as it pertains to the sediment left over by the mega tsunami that now dominates the surface layer and the expression of the land for many tens of kilometres. A really massive area of land was affected by this tidal wave of truly epic proportions. It swept inland for many kilometres, and it would have been a truly terrifying event to have witnessed. And if you're unlucky enough to be in the immediate strike zone, the chances of surviving this type of event are next to none. The evidence that we have of it are in the form of the arrow-shaped depositions that are left behind following the retreat of the mega tsunami, known as chevrons. These chevrons are actually how we found the impact crater to begin with, by studying which directions they went and tracing them back to their source. After which, deep-sea seismic imaging was conducted in the vicinity where scientists thought it may be by ship until the crater was finally found. The cool thing about literally every single town that's built along the coast in Western Australia is that they are all built within these chevrons, blending mankind with the remains of a landscape forged by a truly destructive event, which deposited sediments at a vast scale across the coastlines of Australia. And you can clearly see the effects of it from Western Australia all the way to Tasmania. And I'll cover this in depth in my next episode, and there are some truly spectacular features up and down the entire western and southern seaboard, and on the eastern seaboard there are some unrelated mega tsunami chevrons. So the waves would have absolutely inundated this area when the tsunami first struck, with a very conservative minimum height of 150 meters or 492 feet being attributed to it. Most studies think it was around 180 meters or 590 feet when it reached the shorelines of Western and Southwestern Australia, and that sounds about right. This wave went as far inland as 30 kilometers, and in some areas it went further than this. And the force of the initial impact when the massive wall of water struck everything would have been unimaginable. In some areas, entire cliff faces have been severely eroded to a dramatic extent by this single event, and in the northern parts of Western Australia, scars exist across large areas of the arid land, which have recorded this event better than anything else because of the climate. And whilst we will be covering this in the next episode, here are some pictures of the scars left in the land as a teaser. You can clearly see the direction they were travelling. So if this event happened today, the entire city of Perth would be drowned and destroyed faster than most could imagine. And the wave would travel over the entire city, stretching all the way up to the limits of it, waning in its power most at the beginnings of the ancient cliff face that is comprised of over 2.5 billion year old rocks from the Archean Eon. These cliff faces start about 30 kilometers in, and it more or less broke the wave and stopped it from going too far inland. So if I was to quickly throw over a geological map of this area and take a guess at which layer this tsunami deposit is, I'd say it's either been broken up into two, so it's either both or one or the other in my opinion, but in the description for both the Yilgarn Formation and the Bassendean sand layers make mention of dune quartz sands and heavy mineral concentrations existing, pointing to these two as being the layers. And that would make sense because they are slowly being overlain by the more recently deposited sediments of the Guildford Formation layer, which is the most recent alluvial sediment. Now check this out, this is literally the entire extent of the wave in the grand scheme of things. Look how clear the difference is between the mega tsunami sediment strewn land and the cliff face all along the west coast. This is a rough limit of the mega tsunami. Water did move past here as, based on topographical data, these cliffs are between 124 all the way up to 331 meters, or 406 to 1085 feet in height, with it rapidly changing in topography between the drastic dips in elevation that you see. So we can see some chevrons that have moved past this point, but it's unlikely it really went too far beyond this peak over here. So interestingly and rather unsurprisingly, Perth's topography acted like a beautiful little funnel for this event, which would have contributed to the height of the mega tsunami as it began to ramp up and narrow as it entered through the funnel. Meaning the waves more than likely would have reached their highest here due to the funnel-like topography of the area. So it's actually possible that I'm wrong and that the wave was way higher and went way further. And there are chevron-like shapes that do go inland for many kilometers beyond this point, but I don't know for sure if they are chevrons or just chevron-like shapes from past tectonic events, with geological maps not really helping. I'd actually have to go here in person and take a look for myself or have someone to do it for me. So in general, Perth is about 30 meters above sea level. If a wave, at a very conservative estimate of 150 meters hit this area, well, you can do the math. That's 120 meters, or 393 feet worth of water covering you in an instant, smashing you at a bone-crushing pace when it makes contact, thrusting you into a watery chaos of pressure-induced insanity, taking you along with it for a very violent, tumultuous, and bumpy ride, and death. Poor animals, man, dead set. This would have taken so many animals along with it, and it would have more than likely impacted many indigenous communities too. What an intense and scary event. I'd love to know if any stories of it exist within the local tribes. In Perth today, you can really see the chevrons in the actual city itself. Here's a few over here near Allen Park. The chevrons are really significant on the edge of the beach, and here are some houses that are built into the actual chevron. And look how white these freshly exposed sediments are in these new industrial complexes. This is all deep sea sediment from the 12,500 foot or 3,810 meter deep seafloor of the Indian Ocean where the comet struck. Here we have what appears to be a slide of fine sediment which was thrown across the land rather spectacularly. I'm assuming this happened because it is the lowest topographical point in the area, where the most significant amount of sediment slid tens of kilometers inland. You can see the layers where it was deposited the most. This is Bold Park. It contains the chevron shapes that once would have existed everywhere on this land before it was largely leveled to build a city. So because of this leveling, you might think things don't appear to be that bad, until we get to this point, where habitation and the alteration of terrain hasn't yet commenced on a grand scale, and we begin to see the size and extent of the chevrons that buried this entire area. On the topography, some of these chevrons are between 40 and 90 meters, or 131 and 252 feet in height. Towns are built around them in the lower lying areas. The arrow shape is ever so present everywhere here to a grand scale. This is the type of stuff that Google Maps or Google Earth would have a hard time conveying, and this is where this simulation shines. So these events are truly destructive, as we will learn in the coming episodes, where we cover not only the mega tsunami damage but the deluge that followed. Let's pray that we are on top of any potential impact event that could create another scenario like this one that occurred 5,000 years ago, that our ancestors across the globe somehow survived through, with much difficulty. And I suppose we should thank those guys and gals who did. It's because of their sheer tenacity and utter willpower to survive that all of us are here today. So this is the violent story of how the land that Perth sits atop was constructed. A once flat land suddenly made mountainous after being buried by a huge tidal wave, more than likely stretching far beyond the conservative 180 metre tall mark due to the aforementioned funnel here. In fact, I've tracked what appears to be chevron-like structures up to 100 kilometres inland in some very flat places. One day I'll go there in person to check them out, but the entire land here was dramatically altered after the waves finally receded. The death toll inflicted on life here must have been truly depressing to see, being surrounded by nothing but death in a place that was once home, but that now looks like an alien landscape, dotted with weird muddy sandy hills that are scattered everywhere and that are filled with alien metals fused to deep sea fossils. This was a sad day, but unfortunately it was just the beginning, because the rainstorms that would follow in the coming days are what would really turn this horrible situation way worse, and the death toll to both humans and animals are about to notch up from regional disturbances to one that affects life planet-wide as a result of this. But I think we've had enough cataclysm for one day, and we'll save that for another episode. Thanks for watching. I hope you enjoyed this video. Please consider joining our Patreon or YouTube channel to help me do this full time so I can get the hell away from my shitty job. I spent a lot of time studying this event in the past 2 weeks. I've looked at so many places, from actual topographical data to the simulation, and have spent many hours gobsmacked by the things I saw, and I really can't wait to share them with you. In the next episode, I think there will be some things that will amaze even the scientists themselves who are researching this event, as it will provide a rare in-depth look at the landscape that you otherwise wouldn't get in an accurate way by utilizing the simulator to go to different places. If areas have vegetation, seeing the chevrons are almost impossible on Google Earth or Google Maps. And remarkably, I've found that using the simulator averts this issue and allows us the rare opportunity to glimpse at many of these places' topographical data in a clear, concise and accurate manner without actually travelling there. And I'll be producing a documentary style series on it in the coming days, so subscribe and hit the bell if you'd like to be notified of any future uploads. At the end, I'll compile all the videos into a single episode for easier viewing, so just a heads up about that. Over 1.8 billion years ago, a massive event occurred in our solar system. An asteroid about 10 to 15 kilometers, or 6 to 9 miles across, ended its journey through space in a dramatic collision with Earth. This impact created what we now know as the Sudbury Basin in Ontario, Canada, turning it into a geological marvel. This ancient event laid the groundwork for one of the world's most affluent mineral areas. Today we're going to explore this fascinating chapter of Earth's history, from the catastrophic impact to its influence on the land's geology, and how the remnants of this ancient asteroid continue to shape our world and society. The asteroid's approach would have been a spectacle in the sky, visible for days or weeks before the impact. The asteroid's entry into the Earth's atmosphere would have created a brilliant fireball, lighting the sky with an intense glow. Life existed in its most basic forms, but if observers on the ground did exist back then, they might have seen a bright streak across the sky as the asteroid hurtled towards its collision point. As previously mentioned, the asteroid, which was around 10 to 15 kilometers or 6 to 9 miles in diameter, collided with Earth during the Paleoproterozoic era, some 1.8 billion years ago. The impact site, now known as the Sudbury Basin, was transformed into a fiery cauldron, a temporary lava lake with temperatures high enough to melt rock. The original crater was estimated to be around 250 kilometers or 155 miles in diameter, a vast wound on the Earth's surface. Today, the basin measures approximately 60 by 30 kilometers or 37 by 18.6 miles. The impact created multiple rings, a feature often found in large impact craters on moons and planets throughout our solar system. I made a video on some of the largest impact craters that exist in our solar system, and many of them had this multiple ring feature. The force of the collision would have been felt far and wide. In fact, it would have been felt planet-wide, with shockwaves radiating outwards, destroying everything in their wake. And the earthquake that was produced would have been one of the largest that have ever occurred in our planet's history. The moment of impact would have been cataclysmic. The ground would have shaken violently, and a massive explosion would have sent debris flying for hundreds of kilometers. The heat and pressure would have been so intense that rocks melted, and the landscape was obviously forever altered. A shockwave would have spread out from the impact site, creating tsunamis in any nearby bodies of water. The sky would have been filled with dust and debris, blocking the sun and creating a temporary quote-unquote impact winter. One of the most harrowing consequences of an enormous asteroid impact is the phenomenon that occurs as ejected debris re-enters the Earth's atmosphere. This debris, travelling at incredible speeds, superheats the atmosphere within minutes or even seconds. The temperatures can soar to levels higher than the surface of the sun, reaching several thousand degrees Celsius. This isn't a slow or localised event, it's an instantaneous global catastrophe. The entire planet becomes engulfed in a searing heat wave. This intense heat would literally sterilise everything. After the impact, a central uplift dome remained. This occurred when the Earth's crust, compressed by the force of the impact, bounces back, creating a dome-like structure in the crater's centre. This dome is a characteristic feature of large impact events and is still visible in the Sudbury Basin. The surrounding area would have experienced significant geological changes, including faulting, folding, and the creation of new metamorphic rock formations. The landscape would have been scarred and reshaped, with pristine mountains, valleys, and lakes forming due to the immense forces unleashed. Now, an interesting process unfolded as the Earth began to recover from this event. The intense heat from the impact melted a large part of the Earth's crust, creating a pool of molten rock and metal. As it cooled, heavier elements like nickel, platinum, gold, and copper sank, while lighter minerals floated to the top. This process, known as magmatic differentiation, led to the formation of concentrated metal deposits that exist in layers, which is a dream for someone like me, who loves this kind of stuff. Over time, these deposits became part of the Sudbury Igneous Complex, now the world's largest source of magmatic nickel. More than $1 billion worth of metal ores are extracted each year from this region. The complex comprises several types of rocks, including norite, quartz gabbro, and granophyre. Now, we've already made a video on the largest impact site on Earth, which is located in South Africa, link to that in the description below, and this underwent a similar mineralization process, and as a result of this massive asteroid impact, which occurred only 200 million years before this one, led to the formation of the world's largest gold deposits. The story of the Sudbury Basin is a vivid reminder of these types of catastrophic events. And even though it occurred billions of years ago, it still continues to shape our world and society in significant ways. From the chaos of an ancient asteroid impact, valuable resources were formed. Resources that have fueled human progress for centuries. Thank you for joining us on this exploration of one of Earth's most intriguing geological events. The Sudbury Basin's story is a testament to the interconnectedness of our universe and the enduring influence of space events on our daily lives. Thanks for watching. In the vast tapestry of Earth's history, few events rival the drama and magnitude of cosmic impacts. These cataclysmic occurrences have not only shaped our planet's landscape, but have also played pivotal roles in the evolution of life itself. One such event, both devastating and transformative, occurred beneath what we now know as the Chesapeake Bay. The actual formation of the bay can be attributed to this ancient impact, but the crater is no longer visible in the present day. It's been heavily obscured by preceding sedimentary deposits. These deposits are what led to the discovery of this impact to begin with, as oil is often found within sedimentary basins, meaning this event lay shrouded from human knowledge until as recently as the 1980s. Shocked quartz and shatter cones are present in the rocks. These two features only occur from large bolide impacts or large nuclear explosions, leaving an imprint of the vast forces produced by these events behind in the rocks. So in this video, we'll take a look at the asteroid impact that shaped modern-day Chesapeake Bay in North America. To truly grasp the significance of the Chesapeake Bay impact crater, we must journey back to the late Eocene epoch, approximately 35.5 million years ago. The world was a different place then. Lush tropical rainforests covered the eastern coast of North America, and the waters teemed with marine life, leaving behind dense layers of lime from their microscopic shells after they died. During this era, a massive bolide, perhaps a rogue asteroid or a wayward comet, set its sights on Earth. Hurtling through the vastness of space, it travelled at a mind-boggling speed of about 111 miles or 179 kilometers per second. Its destination, the eastern shore of North America. The collision was nothing short of cataclysmic. As the bolide made contact, it unleashed an energy so immense that it vaporized upon impact, fracturing the granite continental basement rock to depths of nearly 5 miles or 8 kilometers. The immediate vicinity was transformed into a deep crater, surrounded by a terrace-like ring. This depression, which initially spanned about 25 miles or 40 kilometers, eventually expanded to its present diameter of 53 miles or 85 kilometers due to the sedimentary walls slumping inwards. The aftermath was equally dramatic. A mega tsunami, birthed from the impact's sheer force, raced across the land, reaching locations as distant as the Blue Mountains. For a brief moment in geological time, chaos reigned. Over the ensuing millennia, the raw scars of this cosmic collision began to heal. The crater, with its sedimentary walls and massive blocks, played a pivotal role in shaping Chesapeake Bay's topography. The continual shifting of the rubble influenced the flow of rivers, determining the bay's unique contours and waterways. Yet the crater's influence wasn't limited to the bay's formation. The impact had profound implications for the region's water resources. The cataclysm disrupted the area's aquifers, layering freshwater sources above the remnants of ancient salty North Atlantic seawater. This juxtaposition has rendered the lower Chesapeake Bay area vulnerable to groundwater contamination, a pressing concern for its modern inhabitants. For eons, the Chesapeake Bay impact crater lay hidden, its existence unbeknownst to the world. It was only in the latter part of the 20th century that its secrets began to unravel. In 1983, a drilling core off Atlantic City unveiled tektites and shocked quartz grains, telltale signs of a bolide impact. A decade later, oil exploration data painted a clearer picture, revealing the crater's full extent and significance. Today, the Chesapeake Bay stands as a testament to nature's dual character, its capacity for destruction and its ability to rejuvenate. As visitors gaze upon its tranquil waters, few realize the dynamic forces that birthed this magnificent landscape. Beneath its calm exterior lies a tale of cosmic collisions, geological marvels, and Earth's incredible resilience. The story of the Chesapeake Bay impact crater serves as a poignant reminder of our planet's ever-evolving nature. It underscores the importance of understanding our past to navigate our future, especially as we grapple with modern challenges like groundwater contamination. In the grand narrative of Earth's history, the Chesapeake Bay impact crater is but a single chapter, yet it's a chapter that encapsulates the awe-inspiring interplay of cosmic events and Earth's enduring spirit. Thanks for watching. In a world driven by the forces beneath its surface, Earth has a story to tell. A tale of cosmic impacts and fiery eruptions. of life thriving and life extinguished. For a long time, the connection between a falling star and a spewing volcano was considered the stuff of myth and folklore. Still, a theory emerged, tying these catastrophic events together in an intricate dance of cause and effect. In today's episode, we're going to discuss the fascinating link between large asteroid impacts and flood basaltic eruptions. These types of eruptions are massive volcanic events that release a huge volume of basalt lava over large areas, leading to the formation of extensive plateaus. And they can have profound effects on global climate and ecosystems, potentially triggering mass extinctions due to their emission of greenhouse gases and aerosols. This hypothesis, as debated amongst geologists and astrophysicists alike, postulated a fascinating idea. A significant asteroid impact could reverberate seismic waves through the Earth strong enough to spark major geological disruptions on the opposite side, the antipode. The hypothesis was brought to light particularly considering two devastating occurrences. The first was the Chicxulub impact, a cosmic collision that left an indelible scar near the Yucatan Peninsula. On the other side of the world, in what is now India, the Deccan Traps witnessed an eruption of apocalyptic proportions, spewing out a sea of molten lava. Both events tellingly occurred approximately 66 million years ago, around the time a significant extinction event wiped out the non-avian dinosaurs. Then there were whispers about the mysterious Wilkes Land Gravity Anomaly, a massive formation beneath the ice of Antarctica that I've recently covered in a video. Some have suggested that it's an impact site, a cosmic scar that, if confirmed, would be antipodal to another huge volcanic region, the Siberian Traps, where the land seemed to have melted into a plateau of basalt. Could this crater have triggered the most devastating volcanic eruptions Earth had ever known, contributing to the Great Dying, the Permian-Triassic extinction event? However, the narrative spun by the antipodal hypothesis was not without its critics. Some argued that the timing of impacts and volcanic eruptions didn't always match, and the seismic energy from an impact might not suffice to trigger an eruption. There were many instances where massive igneous provinces and impacts did not obey the proposed pattern. The antipodal hypothesis was challenged by alternative theories too. The concept of mantle plumes, upwellings of hot rock from deep within the Earth's mantle, was widely accepted as a likely cause of extensive volcanic activity. But this doesn't mean that an asteroid impact couldn't cause the upwelling of a mantle plume, so whether or not this is the case still remains to be seen. The Deccan Traps, in all their fiery grandeur, stood amongst the most significant volcanic events in Earth's history. Only a few eruptions, like the Siberian Traps, outmatched them. Their history served as a reminder of the immense geological forces that shape the planet and the life it harbours. As the story of Earth unfolds, it is clear that the narrative is filled with more questions than answers. Yet in every theory, and every discovered piece of evidence, scientists glimpse another part of the puzzle, bringing them one step closer to understanding the intricate interplay of the cosmic and the terrestrial, of life, death, and rebirth on our unique planet. Thanks for watching. In the early hours of June 30th, 1908, a mysterious and monumental event unfolded in the remote Siberian wilderness near the Podkamennaya Tunguska River. This event, known as the Tunguska Event or the Tunguska Incident, was characterized by an explosion of immense magnitude, estimated to be around 12 megatons. The blast was so powerful that it flattened an estimated 80 million trees over an area of 2,150 square kilometers, creating a scene of utter devastation. The morning was like any other in the sparsely populated East Siberian taiga until, without warning, the sky was torn asunder. Eyewitnesses reported seeing a bluish light, almost as bright as the sun, streaking across the sky. This asteroid moved at a tremendous speed, leaving a thin glowing trail in its wake. As it neared the horizon, it transformed into a massive fireball, emitting a light so intense that it bathed the surrounding landscape in a surreal reddish glow. The serenity of the Siberian morning was shattered by a deafening explosion. The force of the blast was so immense that it produced a shockwave that knocked people off their feet and broke windows hundreds of kilometers away. The ground trembled and the air was filled with sounds of what many described as artillery fire. The Tunguska event is the largest impact on Earth since records began. Despite its magnitude, the event occurred over a sparsely populated area which limited human casualties. Eyewitness reports suggest that at least 3 people may have died as a result of the explosion. The explosion is generally attributed to a meteor airburst, the atmospheric explosion of a stony asteroid about 50 to 60 meters in size. The asteroid approached from the east-southeast at a high speed of 27 kilometers per second. The explosion registered at seismic stations across Eurasia, and airwaves from the blast were detected as far away as Germany, Denmark, Croatia, the United Kingdom, the Dutch East Indies, and even Washington DC. In the days following the event, night skies in Asia and Europe were aglow, likely due to light passing through high-altitude ice particles formed by the explosion. There were several testimonies from people who claimed to have witnessed the event. At breakfast time, I was sitting by the house at Vanavara trading post approximately 65 kilometers or 40 miles south of the explosion facing north. I suddenly saw that directly to the north over Onkols Tunguska Road, the sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger and the entire northern side was covered with fire. At that moment I became so hot that I couldn't bear it, as if my shirt was on fire. From the northern side where the fire was came strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut close and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that, such noise came, as if rocks were falling or cannons were firing. The earth shook, and when I was on the ground I pressed my head down, fearing rocks would smash it. When the sky opened, hot wind raced between the houses like from cannons, which left traces in the ground like pathways, and it damaged some crops. Later we saw that many windows were shattered, and in the barn a part of an iron lock snapped. Talk about terrifying, this testimony is a very accurate representation of what one would expect to experience during an asteroid impact. Imagine the dinosaurs who faced a wrath hundreds of times greater than this one. It's no wonder they perished at an extinction level. The Tunguska event is a mere shadow of what the dinosaurs experienced. Here's another testimony, published in a newspaper on the 13th of July in 1908. On the 17th, an unusual atmospheric event was observed. At 7:43, the noise akin to a strong wind was heard. Immediately afterward, a horrific thump sounded, followed by an earthquake that literally shook the buildings as if they were being hit by a large log or a heavy rock. The first thump was followed by a second and then a third. Then the interval between the first and the third thumps was accompanied by an unusual underground rattle, similar to a railway upon which dozens of trains are travelling at the same time. Afterward, for 5 to 6 minutes, an exact likeness of artillery fire was heard, 50 to 60 salvos in short, equal intervals, which got progressively weaker. After 1.5 to 2 minutes after one of the barrages, 6 more thumps were heard, like a cannon firing, but individual, loud and accompanied by tremors. The sky at the first sight appeared to be clear. There was no wind and no clouds. Upon closer inspection to the north, i.e. where most of the thumps were heard, a kind of ashen cloud was seen near the horizon, which kept getting smaller and more transparent, and possibly by around 2 to 3 PM completely disappeared. Scientific investigation into the Tunguska event has been extensive, but they all occurred long after the event transpired, with a deepened scientific inquiry occurring roughly a decade after the event. There have been an estimated 1,000 scholarly papers published, with most being in Russian. Because this occurred in 1908, there was limited instrumentation available, so scientists had to rely on eyewitness testimonies and assessments of what occurred. The first geological analysis took place more than a decade after the event, led by Russian mineralogist Leonid Kulik. Kulik's expeditions in the 1920s and 1930s found a zone where trees were scorched and devoid of branches but still standing upright. This led to the conclusion that the object exploded in the air rather than hitting the Earth's surface. Subsequent research has supported the airburst theory, meaning the asteroid blew up above the surface rather than impacting it. There have been findings of microscopic silicate and magnetite spheres in the soil and in the resin of the trees in the area, suggesting an extraterrestrial origin. Chemical analysis of peat bogs from the area also revealed anomalies consistent with an impact event, and spheres were found which contain high proportions of nickel relative to iron, further pointing to a probable meteorite impact. Trees more distant from the centre had been partly scorched and knocked down in a direction away from the centre, creating a large radial pattern of downed trees. The Tunguska event stands as one of the most mysterious and powerful natural events in recorded history. Its study has not only shed light on the potential dangers posed by near-Earth objects, but has also spurred advancements in our understanding of them. The event remains a topic of active research and debate, a puzzle that scientists continue to piece together more than a century later. Thanks for watching. In the heart of Sweden, a colossal scar lies hidden beneath forests and lakes. The Siljan Ring, a testament to a cataclysmic event from 377 million years ago. This ring tells a story of a time when the Earth was very different. During the late Devonian period, our planet was experiencing an evolutionary explosion. In the oceans, early sharks swam alongside armoured fish and corals, while on land, the first forests were emerging, and primitive amphibians began their tentative steps away from water. But amidst this burst of life, a dramatic event was about to unfold. A massive asteroid hurtling through space set its sights on Earth, colliding with what is now central Sweden. It unleashed a force so immense that it reshaped the landscape. Powerful shockwaves radiated outwards, levelling ancient forests and causing the ground to upheave. The intense heat set the world ablaze, and where the asteroid met the sea, gigantic tsunamis surged forth. During the Devonian, the world was experiencing an explosion of biodiversity. However, in the vast expanse of the universe, an asteroid, a gargantuan chunk of rock and metal, was hurtling towards our blue planet. Its trajectory was set, and a region that would one day be known as Sweden lay in its path. The Earth was a vastly different place back then. Vast seas stretched across the horizon, painting a blue canvas brimming with life. Early sharks with their primitive forms navigated the waters, whilst armoured fish glided through the ancient coral reefs. Above the water's surface, the first whispers of forests began to emerge. Primitive plants like lycopods and ferns danced with the wind, casting their shadows upon the nascent land. Amidst this backdrop of burgeoning life, an ominous shadow loomed. Days became a countdown, and the serene region destined to become Sweden was blissfully unaware of the celestial juggernaut hurtling toward it. When the day arrived, it was cataclysmic. The sky was pierced by the asteroid, and in a heartbeat, the land met with the fury of the cosmos. With a blinding flash and a deafening roar, the asteroid slammed into the Earth. The ground trembled with unimaginable force, sending shockwaves that tore through the landscape. The skies turned into an inferno, with fragments from the impact site being catapulted upwards only to rain down as molten projectiles. Forests were flattened in an instant, and the skies were set ablaze with the fiery fragments ejected from the impact site. The once tranquil seas were no refuge either. As the asteroid met the shallow marine environment, it birthed gargantuan tsunamis, waves of such magnitude that they dwarfed anything in living memory. These watery giants raced with abandon, consuming and reshaping everything in their path. In the wake of such devastation, the world was transformed. Where the asteroid had struck, a vast chasm, the Silian Ring, marked the point of contact. The world was plunged into darkness as dust and debris, thrown up by the impact, shrouded the sun, obscuring it and casting the Earth into a twilight gloom. Temperatures plummeted, and what was once a thriving ecosystem now faced a chilling quote-unquote impact winter, turning once fertile lands into frigid wastelands. The rains that followed were no ordinary showers. Laden with chemicals birthed from the fire and fury of the impact, they were potentially acidic, scalding the land and further challenging the resilience of the surviving life. Over time, life began to adapt and reclaim the scarred land. The very heart of the impact, the crater, slowly filled with water, giving birth to what we now know as Lake Silian. This new aquatic haven became home to a myriad of species, each carving out an existence in the shadow of this cataclysmic event. In the deeper recesses of the crater, the intense heat and pressure from the asteroid's touch transformed the Earth's minerals. Shocked quartz, bearing the unique fingerprints of the impact, crystallized amidst the ruins. Deep fractures in the Earth whispered tales of potential oil and gas deposits, legacies of the asteroid's fiery embrace. The Silian Ring, with its ancient scars and tales of cosmic fury, stands as a profound testament to the fragility and resilience of our planet. From the tranquil days of the late Devonian to the cataclysm that reshaped a region and onto the slow march of recovery, this story is a vivid reminder of Earth's ever-evolving narrative. It teaches us that even in the face of overwhelming adversity, life finds a way to endure, adapt, and thrive. As we reflect upon this monumental chapter in our planet's history, we are reminded of the intricate dance between chaos and order, destruction and renewal. The Silian Ring is not just a geological marvel, it's a symbol of the indomitable spirit of life and the timeless saga of Earth's journey through the cosmos. Thanks for watching. Lake Acraman is a shallow saltwater lake located in South Australia. In this arid area of Australia's outback, this seemingly innocuous structure has existed here for around 580 million years, after a massive meteorite suddenly smashed into this part of the world, creating untold devastation in the process. Massive tsunamis were created from this impact event, and the fallout from it would cause far-reaching consequences that would alter Earth for decades to come. Today, we're going to introduce a new tool to this channel so that we can take a better look at Lake Acraman and the impact event that created it. Alongside this, as per usual, we'll also take a look at the magnetics to better define this structure. And I believe there may exist one or two large volcanic calderas of a completely unrelated origin existing right alongside Lake Acraman, which I'll also segue into briefly as the video progresses. Before we get started, I just wanted to thank everyone who donated to the channel's PayPal. Thank you all so much. I've just enabled YouTube memberships, so consider joining for only a few dollars a month by clicking the join button down below. Or if you'd prefer to do a once-off donation, the link to the channel's PayPal account will be both on screen and in the description. I'm looking to scale this channel up so that I can release more content of a higher quality, so every donation or membership is appreciated beyond measure. In time, I'll open up a Patreon too. Let's get into it. Present-day Lake Acraman is hard to read. It's been significantly eroded and is different in terms of how it looks compared to other more circular meteorite craters that exist in Australia and around the world, such as this infamous meteorite crater in Wolf Creek. But make no mistake, this area is without a doubt a massive impact site. In fact, it's actually one of the largest that's been found anywhere on the world. The rock that this meteorite smashed into was primarily lava created by a supervolcanic eruption that took place here 1.6 billion years ago, and it threw this rock very far from the site of impact, with it being launched well over 500 kilometers away during the event. The original crater is 90 kilometers wide, and the velocity that this meteorite struck the Earth at was around 25 kilometers per second. The tsunamis generated by this event would have been unbelievably massive, at least 500 meters in height, with it more likely being closer to 1 kilometer in height. When we examine the rock found directly within the crater, we see the telltale signs of a massive meteorite impact. The two qualities I'm about to discuss aren't found naturally anywhere else on our planet. They are entirely extraterrestrial in their origin and their presentation. The pressures required to form both of them do not occur on the surface of the Earth, and aren't able to be explained by other mechanisms. The first is shatter cones, a very distinct conical feature found in these rocks. The second is shocked quartz grains. These very fine planar fractures are created in tiny quartz grains after they have been subjected to immense pressures. When we fly over Lake Acraman, we see the outcropping of the ancient Gawler Ranges volcanic rock, amongst much more recent lake deposits. As previously mentioned, this impact crater isn't the simple bowl shape often seen and associated with meteorite impact craters, and as a result of this, it's known as a complex crater, because it has a complicated surface with variations in elevations. The reason for this is because over time, the surface has eroded several kilometers below the original crater floor, exposing the more erosion-resistant rocks in the process. When we look at Lake Acraman under the magnetics, we have a further telltale sign of an epic asteroid impact. The center of it is protruding, and I'll explain the reason for this shortly. Life did exist at this point in time in the form of acritarchs, which are small organic microfossils known to exist in the fossil record starting around 1.8 billion years ago and existing all the way to present day. And when this event occurred, a dramatic change in a type of these acritarchs was found in the rock record from this time, which coincides with the estimated occurrence of the Acraman impact, showing just how far-reaching the effects of this event might have been. So what actually happened when this meteorite struck Earth? Well, as the asteroid made impact with the shallow Adelaidean Ocean that existed here 580 million years ago, a blinding light would have flashed forth as the muddy ocean bedrock succumbs to an unimaginable level of heat and energy. It's literally vaporized instantly upon contact when this gigantic extraterrestrial rock makes impact. The meteorite penetrates through kilometers worth of sedimentary material, ushering forth a level of destructivity that stretches far beyond any weapon that humans have ever created. An ever-expanding shockwave is seen as a white sphere that stretches forth in all directions. This shockwave produces massive tsunamis, and the thermal radiation emanating from it travels forth at the speed of light, sterilizing everything in a massive radius around it. The energy of the impact dives into the Earth's crust like a stone being thrown into a pond. The solid bedrock in the immediate impact site loses the ability to be solid, as the meteorite vaporizes it upon contact. This bedrock is melted into a hot plasma, as a 90-kilometer wide crater is created. Just for reference, the asteroid that wiped out the dinosaurs created a 100-kilometer wide crater, so this event is just short of that kind of massive event. The shallow Adelaidean Ocean is thrust back in all directions for hundreds of kilometers, and the liquid consistency of the Earth's crust begins to solidify again and bounce back in a rebounded state, forming this protruding mountain that we can see on magnetics today. Material is blasted from this once peaceful shallow ocean out into space, where much of it then falls back to the Earth as superheated debris, which comes crashing down back into the Earth at incredible speeds. Some of this material will orbit the Earth for thousands of years before it crashes back down though, so not all of it immediately fell back down to the Earth, and some of it may have even reached as far as Mars. But in general, most of it came straight back down. And this is where things took a turn for the worst, which was something you probably thought was impossible at this stage. But it isn't. Because as material falls back to the Earth, it reaches extremely hot temperatures. This material heats up the atmosphere, creating a heat shock, scorching the entire Earth. No trees existed at this time, so no real wildfires were created, but this event would have been felt everywhere on Earth. Earthquakes of a tremendous magnitude 11 would have been produced, and it's possible that this impact event caused immense volcanism on the opposite side of the planet from where the impact site occurred, most likely in the form of flood basalts. It also more than likely caused many volcanoes to erupt, as the shockwaves and earthquakes would have created faults, fractures, or conduits, allowing magma to rapidly ascend, or it might have just raised the pressure levels inside the magma chamber itself, creating a catalyst for violent explosive eruptions to occur. And this would have been both near and far from where the meteorite struck, as the shockwaves travelled in all directions. Much like a volcanic or nuclear winter, a gigantic ash cloud formed by the vaporized material spreads forth in all directions, eventually shrouding the entire planet in a blanket of solar-reflecting aerosols, possibly plunging the entire planet into a deep freeze and ushering forth an era of glaciation. This is where the Acritarchs got hit hard. This shrouding of the Earth temporarily halted photosynthesis, leading to a mass die-off of plankton that the entire ocean ecosystem relied on to survive. This is most likely why there was a significant variance in these organisms pre- and post-impact. When this meteorite made contact with the Earth, the ejecta that it threw up into the surrounding area eventually settled into the mud on the surrounding sea floor. This ejecta is associated with an iridium anomaly, suggesting it had been contaminated with extraterrestrial material, aka the meteorite. Nowadays, this 20-kilometer diameter lake is a shadow of its former glory. Over 2.5 kilometers of the original crater floor has been eroded. We can find the ejecta associated with this event in many places far away from the impact crater. At Bunyaroo Gorge, we have one example of this in the rock layer known as the Bunyaroo Formation. This is a sedimentary layer of shale, which is a grey-coloured deep-water sedimentary rock formed in a marine environment. In these rocks, we see a very sharp break, and distinctive alien rock fragments appear in the rock record which should not be here. These are from the Gawler Range volcanics, which were released far away from this location 1 billion years before the meteorite struck. They are pieces of volcanic rock from Ayers Peninsula, which have been tied in with this sedimentary shale as a result of it landing here after being launched far away from the original impact site. The Gawler Range's volcanics is a very distinct and beautiful pink rhyolite that cannot come from this area. There is no logical source, and it's chemically identical to the Gawler's Ranges volcanics, which travelled 300 kilometres to reach this site. It's safe to say that geologically speaking, this was an extreme event. So that's the story of the Lake Acraman impact crater, one of the largest meteorite craters to exist on our planet. When we fly low and over the middle of it, a quick 360-degree rotation clearly shows the outline of this massive impact crater, with it ending where the mountains begin. It was a truly extreme event that had immense implications for evolution and for the Earth at large. One day, another Acraman-sized meteorite is going to travel our way, and these events will repeat themselves once more on this planet. Let's just hope that we're prepared before that happens. Thanks for watching. Don't worry, I won't leave you hanging. I know I mentioned I might have spotted 2 calderas. I suspect that these might be associated with the Ardea dacite, and if not, then it might be one of the spots where the strange and very unique Gawler's Ranges volcanics was released, which I'll be making a video on real soon. There's a structure that looks to be a pretty visible ring dike here, and another that's only really visible on magnetics. I'm not sure if they're calderas or intrusives, but I'd say they're worth looking into further, and I definitely intend to do that one day when I go there in person. I hope you enjoyed this meteorite topic though. I've been reading your comments and yep, I'll begin making videos that covers events that occurred in other states in Australia other than Victoria, and I'll be beginning a New South Wales series shortly. Thank you all for leaving your comments. It's been a chaotic few weeks for me as I deal with some personal stuff, but I'm trying to reply to as many comments as I can. My work hours are a little insane and it's become a little difficult with the hundreds of comments and emails that I'm receiving daily, but I will try to get back to as many of you as I can as soon as possible. Big things are due to happen in the near future as this channel continues to grow.